Well, good afternoon, and thanks for attending these luncheons. So last time I presented, which was over maybe almost 2 years ago, talked mainly about some federal work that I had done, some state work. So today, when I've been talking with Michael, I'm going to talk to you a little bit more about certain types of work that we do in my research group and how we actually conduct it in terms of even contracting and the types of contracts, the types of projects that we've done, just to give an overview of how we do have partnerships with municipal funding agencies. So first, a little bit about myself. I've been here for, this is my 15th year this week. As a professor, I'm now in civil environmental engineering group. I teach mainly water, wastewater type topics. And I have an industry background. I spent 15, 20 years in the industry as a executive of a design consultancy. And I did research and those types of things. My background is mixed. I have chemistry background with an environmental engineering doctorate. I currently have 3 Ph.D. students work with me, 2 master's degrees and 5 undergraduates. But over the years, I've produced 16 Ph.D.s, 25 master's students, and 3 honors in the major students. And so most of my work is on process engineering. And my research interests are in mass transport, alternative water supplies, chemical engineering type topics, with a lot of the mass transfer being the component of that. Infrastructure in the water systems, which you know is a major thing right now in our nation, and a lot of chemistry. So I would say a portfolio. You know, Michael likes to talk about portfolios. So we get some federal work funding, we get some state funding. We've been funded by municipal governments, which is what I want to talk to you about today, and then also some water districts and some research foundations. So why would you, as an academic type of person, want to work with municipal water utilities and wastewater utilities and these types of groups? And it's because this is really, in our world, this is civilization engineering. So it allows for research that provides insight into things that we take for granted. You get safe water drinking out of the tap, you flush your toilet, you put your garbage out to the curb, out of sight, out of mind, you breathe clean air, and you don't really most people don't really know what's behind what society does for us that we take for granted. And so that's the area that we work. It allows our graduate students to interact with actual practicing society and still be able to do their academic work. So the benefits to them are they can use critical thinking, they get to solve problems, as well as investigate fundamentals. They gain experience working with utility operations, with management, with legal people, with insurance type people, with all sorts of different levels of disciplines of, again, in the practicing world. And, but it demands that they also have to do a deep dive into their subject matter, as well as satisfy the practical needs of the contracts that we get funded. So the contracting options are basically 2 types. It's a direct agreement between the entity and UCF, or it's an agreement with the utilities bond engineer or their engineer of record. It's a pass-through through the government to the professional engineering firm to UCF. So those are the 2 typical methods we have for this type of research. So this is just a list of the types of, since I've been here, these are who we've been funded by and the areas that we worked in. Our group travels quite a bit. Before the pandemic, we were always on the road. We were very rarely on campus. Most of our work is offsite at wherever the utility is. And you can see some of it's federal type work, but a lot of it is municipal governments. So we travel. So I want to talk about a couple of case studies, just to give you an example, flavor of the type of work that we do. For a couple of these utilities I've selected, mainly in Florida. Whereas last time I talked more about the work that we did outside the university. So Polk County, hopefully most of you know that it's a neighboring county government. It's a fairly large population. It's one of the larger counties in the state, but it's also very rural, still a lot of agriculture. And they have over 50 water and wastewater plants that deliver services to their consumers. Just like you go to your home and you get provided services by your utility. It's regulated by the Polk County Health Department, as well as the state, as well as the federal requirements. So over the years, we've had our contracts set up with them initially started with just a specific contract to look at a specific project for one of their specific water plants. But as that turned out, they were so interested in developing the relationship with us, they started giving us multi-year contracts. So where they would give us a master research agreement. And then as the utility needed research in a certain area, they just give us a task. They said, hey, look, we have a problem at like the first one, Imperial Lakes. We have a post-construction issue. Could you come in and investigate, help us solve this problem? And so we've been doing these types of projects over the years, and my students, all the students that work for me, get involved in these things. And so I want to talk about one specific type of project at Babson Park Water Plant. For about $130,000, we did a project for them. And these contract focuses are technical support, research, and then we feed into their operations processes. So if they have to fund a new construction of a new water plant, those types of things, our reports are used to generate those funds. So I've had 2 PhD students graduate off this work and 4 master's students develop their theses based on a lot of those projects you saw. And the most recent one, here's a picture of Jessica Cormier. She just passed her defense this last week. And she worked in looking at genetic profiling of treatment processes. This happens to be granular activated carbon. The reason we use this is to remove pesticides from a water source, to remove natural organic matter from a water source, so that when we disinfect our water, we don't form disinfection byproducts like chloroform. So these systems are designed to protect public health. So when you drink your water, you don't get sick. And so we do a lot of work with optimizing these systems. And in her work, she figured out how to better operate and with the understanding of how the biology worked in these systems to where they're saving $80,000 every operating year for this equipment. And this is a small system, so they don't have a lot of money to spend to begin with. SafeStar is another one of our long-term funding agencies. They're a little more sophisticated water utility. They have a desalination process where they desalt brackish water and turn it into drinking water. And they also have a well field that's 20 miles away from the city that they bring water in through a 20-mile pipeline, and they treat that by a cation exchange, which they exchange the hardness for salt. So they have an advanced wastewater treatment plant and a desalination facility on the same site. So in the lower picture to the left, you'll see an aerial of the overall site that's the water wastewater. It's a huge facility. They're all right there in the same location, and most utilities, they're separated. The picture, there's an intake that is from the Gulf of Mexico that's used to process some of their water for regenerating the exchange. And the far picture on the right overhead showing the ground storage tank is where their other supply of water comes in, and they have to treat those water supplies and blend them and meet the requirements. So we're working at both facilities. And so over the years, we've done several different projects for them. And here's a picture of Paula Campesino, who's one of my doctoral candidates. She's constructed this corrosion rack to do studies because there are new corrosion laws for people to protect people from lead and copper drinking in your water supply at home. We're doing studies with the utilities to optimize their water quality conditions so they reduce the amount of corrosion that they have in the distribution system, right? And so you can see we've done process assessments, chemistry studies, corrosion, a lot of corrosion work. And we're now working with the wastewater plant to look at reusing the wastewater and storing it in the ground, called aquifer storage and recovery. So that's a new exciting area because the regulations are very strict, and it's difficult to deal with the chemistry from reclaimed water. And eventually one day we'll be looking at direct potable reuse from our wastewater supplies, which is somewhat controversial. We're negotiating for additional work with them. We right now have two $200,000 contracts that we're working on, and they want to get us more involved in some additional work that they have in mind for us. The outcome for Sarasota has been 3 PhDs. I have 2 more graduated in the spring, and I've had 2 master's students, and we've published a number of publications in technical journals with our results, and we've helped them save $100,000 a year operating costs in one of their plants processes. And the work that we've done has helped them secure a $100 million bond for their improvements that they're going to currently undergo for the infrastructure for the water and wastewater facilities. And the last group I want to talk about is Jupiter Water Utilities. They rely on, whereas the first 2 I talked about rely on a direct contract with UCF, Jupiter retains and they search and they change their consultants every so many years under the Competitive Consultants Negotiation Act for professional engineering services. And so we have to work whoever their design engineer is. And so they pass through their research studies through them, and we have meetings. The students participate in all the high-level meetings with at times elected officials, at other times, most of the time it's with the utility director, utility management, operations management for these facilities. In fact, one of my former students is now one of the managers in the utility. So I have to, my prior student is now my boss, I guess you could say. And so we've done a lot of advanced technology research for this group. This is a very sophisticated utility, one of the most sophisticated utilities in the state of Florida. They have, you can see on the site of the picture, it's showing the boxes of the desalination facility. The long rectangular is the nanofiltration, state-of-the-art, what's called a nanofiltration membrane process. And we typically get about $180,000, $100,000 a year where we integrate our students into their utility and do a tremendous amount of different projects, but the students are required to pull the academics out. And so we've done sulfuric acid studies, we've done disinfection studies, we've worked with endocrine disruptors. You might have heard about that's a big issue now in the environment. And we're assessing now zero discharge operations. So here's the utility actually constructed the pilot plant. That's the middle picture down below. It's a $400,000 piece of equipment. They built it and said, here, we want you to use this to help do your studies. So that's kind of nice. I've produced 2 PhDs out of this work and 4 master's degrees. And here's some of our publications with some of the students shown in the picture. As term as collaborations, I'm working with, I've been working with Melanie Beasley. We're going to try to integrate her into one of our projects with Polk County in this next, the next funding cycle with them. I've worked with Fred, but some of you may know Fred Bletcher, who's now the dean, one of the associate deans at FAU and in civil engineering. I work with Graham Bell from Tennessee, Arizona State, do some work with Maria Kennedy over the years. She's at Delpt. And then, of course, we have our industry contacts. So my near term is a few new contracts in 2022 with City of Sarasota that we're working on. We're extending some other contracts. We're going to get a new master agreement next year for another 4 years, I think, with Polk County. And I'm working on an NSF proposal with structural with Dr. Mackey and Dr. Sun. Dr. Sun's one of our new assistant professors. And I'm interested in that. I like working integrated with the civil engineering folks. And then we're looking at, Jessica's going to focus on what we call predator bacteria and some GAC filter operations on to help them understand better how to operate these. Water, drinking water is not sterile. So some people misinterpret that. So you're going to have bacteria growing in these systems. Long term, basically continue what I do and work with students. And I think that's pretty much it. Here's some pictures of some funding agencies that we worked with over the years. And here's some of the students I've had in the last few years.